In the silent theater of the cosmos, celestial bodies perform a ballet governed by gravity and time. But what happens when one of the dancers simply vanishes? The universe is a place of creation and destruction, but the idea of an entire planet disappearing from view feels like a cosmic magic trick. This isn't science fiction, like the destruction of Krypton. Astronomers are now confronting real-life cases where planets have faded into nothingness, leaving behind profound questions about the life, death, and ultimate fate of worlds. These celestial enigmas reveal a universe that is far more dynamic, violent, and ephemeral than we might imagine. Our story today begins with a ghost in the southern sky, a world named Fomalhaut b. Once celebrated as one of the first exoplanets to be directly imaged, its subsequent disappearing act has become a blueprint of how planets destroy each other. In the constellation of the Southern Fish lies the brilliant star Fomalhaut, just 25 light-years from Earth. Fomalhaut is surrounded by a vast ring of icy debris, much like our own Kuiper Belt, suggesting it's a place where planets are born. It was here, using the Hubble Space Telescope, that astronomers made a landmark discovery. In 2008, based on images from 2004 and 2006, they announced they had captured a direct image of an exoplanet, a moving dot of light orbiting the star. This was a monumental achievement. Most exoplanets are found indirectly by detecting the wobble of their star or the dimming of its light. To actually see a planet was a game-changer. The world was named Fomalhaut b, and it was hailed as a massive world, perhaps 3 times the mass of Jupiter. But right from the start, Fomalhaut b was a puzzle. It did things a planet should do. For one, it was unusually bright in visible light, yet it gave off no detectable infrared heat when observed by the Spitzer Space Telescope. Young, massive planets are expected to be warm and glow in the infrared. Astronomers thought maybe a huge ring of dust was encircling the planet, making it bright. The second puzzle was its orbit. Its trajectory was highly unusual, suggesting it might even be on a path to be flung out of the system entirely. The mystery deepened as astronomers kept watching. Follow-up observations showed the object was gradually fading. Then, in images taken in 2014, the final, shocking twist was revealed. Fomalhaut b had vanished. A planet, once so vividly captured, was gone. As astronomer András Gaspar of the University of Arizona put it, clearly, Fomalhaut b was doing things a bona fide planet should not be doing. Its disappearance was the final nail in the coffin for the planet theory. A real planet doesn't just fade away in a decade. Gaspar and his colleague George Reike proposed a dramatic solution. Their conclusion was that Fomalhaut b was never a planet at all. Instead, what Hubble had witnessed back in 2004 was the immediate aftermath of a titanic collision between 2 large, icy bodies. They calculated that a smash-up between 2 planetesimals, each about 200 kilometers across, would create a colossal, expanding cloud of very fine dust. This cloud, lit by the brilliant light of Fomalhaut, is what appeared as a single bright dot. This hypothesis neatly solved all the puzzles. An expanding dust cloud wouldn't be massive enough to generate infrared heat. The dust would also be pushed outward by the star's radiation, explaining the strange orbit. And most importantly, it explained the disappearance. Over a decade, the dust cloud continued to expand and disperse. By 2014, the particles had spread out over an area larger than Earth's orbit around the Sun. This made the cloud so diffuse that it fell below Hubble's detection limit, effectively vanishing from sight. Astronomers had been at the right place at the right time to witness the violent prevention of a planet's birth. The case of Fomalhaut b became the first time we had directly witnessed the aftermath of a planetary-scale collision in another solar system, opening up the larger story of how worlds can be lost. The tale of Fomalhaut b is spectacular, But it's just one of several violent ways a planet can be erased from the cosmos. One of the most common fates for a planet is to be swallowed by its aging star. Stars like our Sun are stable for billions of years, but when they exhaust their hydrogen fuel, they swell dramatically into red giants. A Sun-like star in its red giant phase can expand to 100 times its current diameter. In about 5 billion years, our own Sun will do this. Its expansion will consume Mercury, Venus, and quite possibly Earth. A planet caught by the expanding stellar atmosphere experiences immense drag, causing it to spiral inward until it's completely vaporized and assimilated into the star. Astronomers have found compelling evidence of this happening elsewhere. One key clue is the element lithium. Lithium is usually destroyed inside stars, but scientists have found some red giants with abnormally high amounts of it. A leading explanation is that the star recently ate a planet. The act of a planet-sized mass spiraling into the star can trigger processes that create a fresh supply of lithium on the surface, a temporary chemical signature of the planetary meal. In one case, the red giant star BD plus 48740 had high lithium levels and a surviving massive planet in a strange elliptical orbit. Astronomers deduced the strange orbit was likely the result of a gravitational kick it received when a now missing inner planet was devoured by the star. Catching this in the act is hard, but in 2023, astronomers announced they had for the first time witnessed a star swallowing a Jupiter-sized planet, observing a distinctive flash of light, followed by a stream of dust. Such events suggest stellar engulfment is a routine, if brutal, part of a solar system's life cycle. As the Fomalhaut B saga shows, direct collisions are another potent method of planetary destruction. Early solar systems are chaotic places, like a cosmic shooting gallery, with many small protoplanets jostling for position. These collisions can have different outcomes. Two gas giants might merge. A massive impact might strip a planet of its atmosphere, leaving only a dense core. In the most extreme cases, a collision can shatter one or both bodies into a massive field of debris. Our own solar system bears the scars of such violence. The leading theory for our moon's formation is the giant impact hypothesis. It suggests that about 4.5 billion years ago, a Mars-sized protoplanet named Theia collided with the early Earth. This cataclysmic impact ejected a tremendous amount of molten rock into orbit, which then coalesced to form the Moon. Evidence for other destroyed worlds might exist in meteorites. Tiny diamonds found within a meteorite that fell in Sudan in 2008 are believed to have formed under immense pressure deep inside a planetary embryo, roughly the size of Mercury or Mars, that was destroyed in a collision in the early solar system. More recently, astronomers have looked for collisions around other stars. The young star RWRA has been dimming periodically for decades. Observations with the Chandra X-ray Observatory revealed that the material blocking the star's light was rich in iron, suggesting the dimming was caused by a thick cloud of debris from a recent collision between two infant planetary bodies. Perhaps the most violent form of destruction happens when a world strays too close to a supermassive black hole. An object that crosses a boundary called the Roche limit will be torn apart by extreme tidal forces. The gravitational pull on the side of the planet closer to the black hole is so much stronger than the pull on the far side that it stretches the planet apart in a process graphically known as spaghettification. The planetary material is pulled into long streams. Some is flung away, while the rest forms a swirling, superheated disk that spirals into the black hole. As this material is consumed, it releases a brilliant flare of energy called a tidal disruption event, which can outshine its entire host galaxy for months. While most observed events involve stars, the same physics applies to planets, completely obliterating them and leaving only a brief flash of light as a final epitaph. But not all planetary disappearances are so sudden. Some worlds fade away over billions of years as their atmospheres are stripped into space. This is particularly relevant for planets called hot Neptunes. Astronomers noticed a strange missing planet phenomenon. They find plenty of small, rocky super-Earths and large, gassy hot Jupiters, but a surprising scarcity of planets with a size between 1.5 and 2 times that of Earth. This is called the Radius Valley. A leading theory to explain this gap is core-powered mass loss. The idea is that these intermediate planets have thick atmospheres, but their cores aren't massive enough to hold onto them. Over billions of years, intense radiation from the star or heat from the planet's own core energizes the atmospheric gases, causing them to escape into space. This process effectively evaporates the planet's atmosphere, shrinking it down until only its rocky core remains. It transforms from a sub-Neptune into a super-Earth. The exoplanet GJ3470b, for instance, is losing its atmosphere at such a prodigious rate that it has been described as a slowly disappearing planet. This gradual stripping doesn't destroy the planet entirely, but it causes worlds of a certain size to vanish from their population group. Sometimes, a planet disappears for the simplest reason: it was never really there. The case of Fomalhaut b is the perfect example of mistaken identity. Detecting exoplanets is incredibly hard, like spotting a firefly next to a searchlight from miles away. This can lead to misinterpretations. Objects often mistaken for planets include faint background stars, or even distant galaxies that happen to be in the same line of sight. Careful observation can usually rule this out, as a true planet moves with its star. Another way for a planet to vanish from its solar system is to be thrown out entirely. These lost worlds aren't destroyed. They're ejected to roam the cold, dark void between stars as rogue planets. Early solar systems were crowded and chaotic. Computer models suggest our own solar system may have once had an additional ice giant, a fifth gas giant. A close encounter with the powerful gravity of Jupiter or Saturn could have flung this fifth giant out of the solar system completely. These rogue planets are incredibly difficult to detect. They emit no light of their own. However, astronomers have found evidence of them through gravitational microlensing events, where their gravity briefly bends the light of a distant star. Some estimates suggest there could be trillions of these wandering worlds in our galaxy, more numerous than the stars themselves. They haven't disappeared from the universe, but they have vanished from the systems that gave them birth. Solving these cosmic mysteries requires persistent observation with our most powerful tools. The story of Fomalhaut b was pieced together over a decade using archival data from the Hubble Space Telescope. Today, the James Webb Space Telescope can peer through dust to study collisions. The Chandra X-ray Observatory can detect the high-energy radiation from these events, and ground-based surveys like the Zwicky Transient Facility can scan the sky for sudden changes, like a star swallowing its planet. By combining data from across the spectrum, astronomers can build a complete picture of these cataclysmic events. The interstellar enigma of the disappearing planet pulls back the curtain on a universe of breathtaking violence and constant change. We have learned that planets face a gauntlet of existential threats. They can be swallowed by their suns, shattered in collisions, shredded by black holes, or have their atmospheres boiled away. They can even be cast out as lonely wanderers. These events are not anomalies, but fundamental features of galactic evolution. They remind us of the profound impermanence of even the grandest celestial bodies, and of the thrilling, unending quest to understand the dynamic cosmos we inhabit.